Hello students, 8th English medium. As you know from yesterday's session, we started the revision of chapter number 1 in mathematics. We did some blanks. Now we move onward. Here we have to state the which properties are used. So the question is state appropriate properties. So in each statement, which property for addition or multiplication is there, we have to mention it. First one, 2 by 3 and 5 by 3 are rational numbers. Therefore 2 by 3 plus 5 by 3 is also a rational number. We know that the first property we learned, that when we add two integers or two rational numbers, answer again is a rational number, which is known as the closure property. So it is closure property for addition. Closure property for addition, that is our answer. Question number 2. Minus 3 by 5 plus 0 is minus 3 by 5 again. We know that it is the additive identity 0. So we can write down existence of 0 as additive identity. Because when we add 0 to any rational number, answer is again a rational number itself. Number 3. Bracket minus 2 by 7 plus 4 by 9 plus 8 upon 11 is equal to minus 2 by 7 plus 4 by 9 plus 8 by 11. So here you can see that three rational numbers can be added by making any desired groups. That the associativity, or you can say associative property for addition. So associativity for addition. So we can make group of those two numbers, or you group of two numbers. Anyway, answer will be the same. So that is the property associativity. Number 4. Minus 7 upon 13 plus 7 upon 13 is equal to 0. And that is we know that existence of additive inverse, because when we add the number and its additive inverse, answer is 0. It means that it is the existence of additive inverse. So it is existence of additive inverse. Existence of additive inverse. Then number 5. Four upon 17 plus minus 5 upon 17 is equal to minus 5 upon 17 plus 4 upon 17. So here we add two integers, two rational numbers in any order. It doesn't matter, answer will be the same. And that is the commutativity for addition. So it is the commutativity for addition. Then the sixth one, 5 upon 12 and 7 upon 11 are rational numbers. Therefore, 5 upon 12 multiplied by 7 upon 11 is also a rational number. That is the same property here we used, but that was for addition. That is a closure property for multiplication. So, closure property for multiplication. Seventh one, three upon 7 multiply by 7 upon 3. So product of which two numbers is 1? If they are reciprocals of each other. So we can say that existence of multiplicative inverse, or you can say it is reciprocal also. Existence of a reciprocal or existence of multiplicative inverse. Then next, minus 2 upon 5 multiplied by 4 upon 7, 4 upon 7. So it is same like that, but it is commutativity for multiplication. So commutativity for multiplication. So it was the commutativity for multiplication. Ninth one, minus 5 upon 8 multiplied by 1 minus 5 by 8. Same like this, existence of 0 is additive inverted identity. Here existence of 1 as multiplicative identity. So existence of 1 as multiplicative identity. Then the 10th one, minus 1 by 2 multiply by 3/4 multiply by 5/9 is equal to -1/2 multiply by 3/4 multiply by 5/9, and that is the associativity for multiplication. Associativity for multiplication. And the 11th one, -3/5 multiply by into bracket 1/2 plus 3/4 is equal to -3/5 multiply by 1/2 plus -3/5 multiply by 3/4. Now we know most, when multiplication and addition together, it is distributivity. So distributivity of multiplication over addition. So whenever it is like that, outside that multiplication sign, inside there is plus sign, then it is the distributivity property of multiplication over addition. Now we will represent the numbers on number line. So first one is represent two integer 3/5 on a number line. Now generally what do we do when we represent number line? We start from the 0 and then between 0 and 1, 1 and 2, 2 and 3, make the equal parts as in the denominator. And then we take the parts total which are in the numerator. But if a number is a mixed number, you need not start from 0. In mixed number, check which is the integer part and which is the other part. So here you can see that number is 2 integer 3/5. It means that number lies between 2 and 3 only. So we can take the limited part also of the number line and you can represent like that. So here you can directly do like that, that here 2 integer 3/5 lies between the integers 2 and 3. So now we have to make 5 equal parts between 2 and 3. So now we have to draw a line. You need not take 0, 1, everything, because it is 2 and 3. So you can take 2 here, 5 equal parts. So take 1 centimeter, 1 centimeter, 3, 4 and 5. 1, 2, 3, 4. And at the 5th, you can write down the 3. Now in the integral part it is 2. But in the ratio, that other part, 3/5, fraction. In fraction, 3 is in the numerator. So from the left side we have to count first, second and third. So here we will count first, second and third. So that number will represent 2 integer 3 by 5. So you can do a circle around it also to represent that 2 integer 3 upon 5. So when there is a mixed number, you need not to start from 0, because it is clear that it is bigger than 2. It means it is between 2 and 3. So if it is 3 integer something, then it will be between 3 and 4 and so on. And therefore, we don't have to take from 0. We will take another example also for the negative number. Like we will take represent minus 3 integer 7 upon 3. Minus 3 integer 7 upon 3. It means that that number will lie between minus 3 and minus 4. So here minus 3 integer 7 by 3 lies between minus 3 and minus 4. So now, as we did here, we have to make 3 equal parts between only minus 3 and minus 4. So we know that in the negative integers, minus 3 will be on the right side, minus 4 will be here. So how many parts we have to make? 3 parts. So 1, 2 and 3 equal parts. So here it will be minus 4, and then from left side we have to count. No, here actually we take the wrong thing. We can't do like that. Wait, we will do like represent minus 3 integer 4 upon 7. So now we have to make 7 equal parts between minus 3 and minus 4. Here minus 3 integer 4 upon 7 lies between minus 3 and minus 4. So now between minus 3 and minus 4 only we have to make 7 equal parts. So 1, 2, 3, 4, 5, 6, and the 7th part is minus 4. So now we have to take the 4th part. So 1, 2, 3 and 4th part. That will represent minus 3 integer 4 upon 7. So we took one positive and one negative example so that you will understand that whenever there is a mixed number, what we have to do, we won't have to take from 0. Now we will take another one example when there is decimal number. So represent we can take like a 3.7 on number line. So when we represent here also, we need not start from 0, because it is 3.7 means it is between 3 and 4. So we have to draw like that. And between 3 and 4 we have to make 10 parts, because decimal numbers means 10 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 part will be 4. So now 3.7. So after 3 we have to count 1, 2, 3, 4, 5, 6 and 7. So that number will represent your 3.7. So as I told you, you don't have to start every time with the number 0. When there is a mixed number, then check what is the integral part, that number, and after that which number comes. then you can only take that part. Similarly in the negative numbers also, and in the decimal number also, we don't have to start always with the 0. Yeah, if it is that other given fractions, normal that we already learned, then you have to start from 0, because there are sometimes so many numbers to gather to represent on the number line. Then we have to start from 0. Otherwise, need not to be started with the 0. So here we are going to finish today's session. Will be followed by PDF file. There will be some homework also. Write down in your notebook, and any problem write down in the comment section. Thank you very much.